For today's video, we're going to be discussing the units of concentration and how to calculate the concentration of the solution. So to start out, let's define what concentration is, which you should have already read through your notes for this week, and you would have seen that concentration is, simply put, the amount of solute, or the substance that gets dissolved, that is in an amount of solvent, or the generally liquid or other substance in which the thing is being dissolved into. And so in the picture here we can see the difference between a low concentration and a high concentration. When there is a low concentration, a lot of times we will call that dilute, which just means there's not very much solute, or that there's a lot of solvent compared to your amount of solute. If you look at the picture on the right, the larger number of dots represents having more solute within the amount of solvent. Okay, and so that would be a higher concentration, and so we can actually have a numerical value which we give to that concentration to be able to know how concentrated or how dilute your solution is. So in general, we can take this definition, amount of solute dissolved in an amount of solvent, and we can turn it into a mathematical definition where you see the fraction of amount of solute divided by amount of solvent. And that's the general mathematical equation we use for concentration. If you want to increase your concentration, because it's essentially a fraction, you can increase your amount of solute, making the fraction bigger on the top, or you can decrease your amount of solvent, making your fraction smaller in the denominator. So I'm going to write that. We could increase solute or decrease our solvent. I should say solvent. Okay, if we want to lower our concentration, we can make the numerator smaller, which will make our overall concentration lower. So that means decreasing our amount of solute. Or the opposite is we can increase the denominator by increasing the amount of solvent. Or if we think about a typical solution, our solvent is this white space. It's usually a liquid, because usually we have a solid dissolved in a liquid. And our solute would be represented by the red and blue particles. Okay. So the three equations that you need for concentration are molarity, percent by mass, and molality. These three equations are listed here. They use basically just solute divided by solvent in all of them, except the unit that is important for the solute and for the solvent changes in each instance. So, like for example, in molarity, it's called molarity because you use the moles of solute in however many liters of solvent. Whereas if we look at percent by mass, you can take the mass or the grams of the solute and divide it by the grams of the solution and then multiply by 100 to make it a percent. So these are our three main equations that we're going to be using for concentration. There are other ones out there, but for now we're not going to worry about those. Okay, so let's look at molarity and do a couple examples. So we have our equation, and we want to know if I mix a certain amount of stuff into a certain amount of solvent, and it all dissolves, what is the molarity of my solution? So for example 1, we're going to calculate our molarity of a solution when we have 3.4 moles dissolved in 8.5 liters. So molarity is M. This is for example 1. M equals the moles of solute, so it's saying that we're dissolving 3.4 moles. That's talking about our solute. We don't even know what it is because it hasn't given us a chemical formula or anything. 3.4 moles of solute dissolved in 8.5 liters of solution. And I'm going to need a calculator. I have 3.4 divided by 8.5. My answer is 0.4, and you would write the unit as capital M. Capital M really is the same thing as mole over liters. So you can write your unit either way. This would be my answer, and this is the most common way you'll see the concentration expressed. Oops, I forgot about example 2. All right, so number 2. We sometimes might be asked to work backwards. There's a lot of different types of problems. We could be given grams instead of moles and therefore have to convert. Sometimes we have to work backwards and we'll be given the concentration of the solution and either the amount of solute or the amount of solvent and be asked to solve for whichever one we're not given. So in this question, it's asking how many moles. So that means we're looking for our solute. I'm sorry, let me close that off. And we are given the 650 milliliters. That will be the volume of our solution, which is basically the same thing as the volume of our solvent. So we're given our solvent, and it tells us the concentration of our solution is 3m, or 3 molar. Okay, so we're given these 3 pieces, so we're going to need to solve for moles of solute to get that by itself. So let's remember rearranging equations. Liters solvent. Okay, so the thing that I'm looking for is my moles of solute. Since this is in the numerator, I can easily get it by itself by taking the thing out of the denominator and moving it to the other side. And since this is currently being divided into moles, I can multiply on both sides by liters to move it away. So I'm just going to do that, multiply on both sides by liters solvent. And that'll cancel it on the right side and it'll move to the left. So basically my molarity times my liters will equal my moles. So I'll take my molarity, 3m, times my liters. Actually, I forgot to convert this to liters. 650 milliliters, we can divide that by 1,000 and that will convert from our milliliters to liters. So that's 0.65. Alright, so that is what we're going to plug in. So 3 molar times 0.65 liters, and let's see what we get. Clear. 3 times 0.65 is 1.95. And our answer should be in moles because that's what we were looking for. All right. So there is the answer to that question. All right, moving along. That is molarity. The next type of concentration that we could be looking at is percent by mass. And this is another way that we can express the concentration of a solution. And you might see this at the store on a bottle or frequently in certain disciplines like biology. But basically, we're going to calculate our percent by mass, which I wrote in the equation as mass percent, by taking the mass of our solute, dividing it by the mass of the solution, and multiplying by 100. Okay, so what's important here is to recognize that the solution has 2 components, the solute and the solvent. So if we want the mass of the solution, we're going to have to add those together. So I'm going to write that real quick. This is solute, grams of solute, plus grams solvent. And on the top, we just have grams of solute. Okay? All right, so let's look at example 1. What is the mass percent of a solution containing 0.05 moles of glucose in 0.15 liters of ethanol if the density of ethanol is 0.81 grams per milliliter? Okay, there's going to be a lot of converting going on when we talk about solutions because we need everything to be in the correct units. So first, we need to find the mass of our solute, and then we need to find the mass of our solvent so we can get our mass percent set up. So if you recall, to go from moles to grams of a substance, we multiply by molar mass. I'm just going to write mm. That means molar mass. Okay? So if we have 0.05 moles of C6H12 O6, we would have to multiply by the number of grams there are in 1 mole. Okay, so in 1 mole of glucose, if you add up all these grams from the periodic table, 6 carbons, 12 hydrogens, 6 oxygens, you get 180 grams. That's the amount of grams there are in 1 mole of glucose. So take 0.05 and multiply it by 180. And you would get 9 grams of C6H12O6. Okay. Then we need the mass of our solvent. So this was our solute. So for our solvent, we're given the density and the volume. So if we have our volume and our density, we can use that to find the mass. And this is according to the density equation. Density equals mass over volume. The one thing that we need to pay attention to is that this is in milliliters in the density, and this is in liters. So let's go ahead and convert our liters to milliliters. If before we divided by 1,000 to get away from milliliters, now we're going to multiply by 1,000 to get towards milliliters. So I'm going to do 0.15 liters times 1,000 mil per liter, and that will change it back to milliliters. So I'll get 150 mil. Okay. Now, if we have our volume here, this is the volume of our solvent, and we have the density, that means we need to get mass by itself. And mass is right here in the equation. So we need to multiply on both sides by V. So D times V equals M. So that means that my mass of solvent will be 150 milliliters times 0.81 grams per milliliter, my density. Okay? And as you can see here, milliliters cancel and we're left with grams, which is what we want when we're looking for mass. And this is going to be our solvent. Make sure that's written clearly. So I'm going to take 150 and multiply by 0.81. And I've got 121.5 grams ethanol. So I'll just simplify to F. Okay. Now let us go ahead and prepare to find the mass percent of our solution. So we got to take the mass of our solute, we already found that, 9 grams, over the mass of our solution. So the solution then is our solute plus our solvent, like we already said. So that's going to be 9 plus 121.5, and we are going to get 130.5 grams solution. Okay. So to calculate the mass percent, let's come over here. Percent by mass, you might see it written like this sometimes. It's equal to, I'm going to have to erase something in a second. Is equal to our 9 grams of glucose, our solute, over the 130.5 gram solution times 100. And we're going to run out of time after this problem, but let me go ahead and get that percent for you. 9 divided by 130.5 equals, I have 0.069. So if you multiply that by 100, you get 6.9%. So this would be the percentage of the solution. It's not a very high percentage because it's not a very high concentration. Okay, in the next video we'll continue on and then look at molality.